We've talked about solving exponential equations. Now we're going to switch and do the opposite and solve logarithmic equations, or solve logarithms. So similar to the way we use logs to solve exponential equations, we will need to use exponentials to solve for logarithmic equations. So for example here, we have log base 4 of x plus 3 equals 2. We need to somehow get rid of that log base 4. We've got to figure out what can we do to get rid of the log. Well, we know the opposite of a logarithm is an exponential, and specifically the opposite of log base 4 is the exponential 4 to the x. So we raised both sides to the power of 4. So what we've done here is actually make both sides the exponent of 4. So 4 raised to the log base 4 of x plus 3 equals 4 raised to the second power. So the 4 and the log base 4 cancel out, leaving just x plus 3. And 4 squared, or 4 to the second power, is 16. So then we just subtract 3 from both sides, and we get 13. So the key here is to remember what cancels these things out. Log base 4 is canceled out with 4. Log base 7 would be canceled out with 7. Common log would be canceled out with 10. And the natural log would be canceled out with, well, let's look at that. So let's try this example. 3 times the natural log of 2x equals 12. Now before I get rid of the natural log, I need to move the 3 over. So let's divide both sides by 3 first. We get the natural log of 2x equals 4. And I want to get rid of the natural log. So you have to remember that natural log is really log base e. So the thing that cancels out the natural log is e. So we make both sides powers of e. So again, what you're doing is you're making both sides become an exponent of e. So e and natural log cancel each other out, giving you 2x, and then you have e to the 4th. Then the last step would be to divide both sides by 2. So I get x equals e to the 4th over 2. So let's pull out our calculator and see what that is equivalent to. So e raised to the 4th power, make sure you close the parentheses, and then divide by 2. So it's about 27.3, we'll say. Okay, those squiggly lines just mean approximately, so just since I'm rounding, I put those. Okay, now, you've been wondering probably why we had to bother learning all of those different properties of logarithms. Well, here's one way that they're really helpful. We have log base 2 here. The problem is I can't do both sides raised to the 2 as it stands right now, because the logs won't cancel out because I have 2 of them. The 2 can't cancel out 2 different logs that are being added together. So that's not going to work. So just to say it again, we can't start right now by raising both sides to the power of 2, or making both sides powers of 2, excuse me, because we've got 2 different ones added together and they won't both cancel out that way. So what we want to do is combine this or condense this into one single logarithm. So if you remember, we said we can change 2 logs being added together to 1 log where the insides are being multiplied by each other. So if you're not familiar with this rule, I would encourage you to go back and watch the video on log properties, expanding and condensing. Okay, now that there's just one single log, I can, since it's a base 2, I can cancel it out with 2. So I make both sides powers of 2, and then 2 cancels out with log base 2 and gives me x times x minus 7, and 2 cubed is 8. Alright, now this one is going to take a little more work. We're going to have to go and distribute the x, and then subtract the 8 over. Because what we'll now have to do is factor. Okay, remember, if you have 2 x's that are not the same power, you're pretty much always going to have to factor. So let's find 2 numbers that will multiply to be 8 and add up to be negative 7. Well, that would be negative 8 and positive 1. So we set both of those equal to 0 and solve for x. So we get x equals 8 and x equals negative 1. However, we have a problem. We can't, or excuse me, let me just put it this way. We need to check and make sure our answers work, because if you recall, we cannot take the log of a negative number. So let's start by looking at 8. Okay, if I plug 8 in for x, that's no problem. 8 minus 7 is positive 1. That works too. So 8's great. But negative 1, if I plug it in right here for x, gives me log of a negative number, which I can't do. I can't do the log of 0 or any negative numbers, so I have to throw that answer out. And I just use x equals 8. So if you get two answers in particular, it's a good practice to check all the time, but particularly if you get two answers, you need to check them both and see if they work back in the original, because you cannot log a negative number. Alright, so here's a model. It says n equals 461.87 plus 299.4 times the natural log of x. So that's not a 1, that's natural log of x there. Models the thousands of workers in the environmental industry in the U.S. X years after 1979. By which year will there be 1.5 million, which, since we're working in thousands, that's the same as 1,500,000 workers. Okay? So they give us the number of workers and ask us for the number of years. Well, the number of workers is n, so I plug in 1,500. Again, it's in terms of thousands, so that translates to 1.5 million. And I need to solve for x. Okay, well, my first step here is going to be subtract 461.87 from both sides. So let's see what that gives us. 1,500 minus 461.87. And we get 1,038.13. Okay, now we need to divide both sides by 299.4. See what that gives us. Whoops, sorry about that. Divide by 299.4. We get 3.467. And that equals the natural log of x. Now we have to remember, how do we get rid of the natural log? We do it with e. We make both sides powers of e. Then e cancels out the natural log. So I end up with x equals, and I will plug e to the 3.467 in the calculator. So I do e, and since I want to use, I don't want to round my answer till the very end. So don't just plug in 3.46 or 3.467. Use second answer so it plugs in the exact number in your calculator, because that answer just plugs in whatever was the previous answer. So we get just over 32 years. So since they're just asking for the year anyway, I'll just write 32. And it's going to be 32 years. If we go back and look, it says 32 years after 1979. I'm getting that from right here. So 32 years after 1979. So that would be 2001, if I'm not mistaken. Excuse me, 2011. So 32 years would be the year 2011. So they would estimate that in the year 2011, there would be 1.5 million workers in the environmental industry.